Well, now let's show that e to the x equals the sum of its Maclaurin series for all x. And remember, the Maclaurin series for e to the x is the sum from 0 to infinity of x to the n over n factorial. I need to show that for any value of x, the remainder goes to 0 as n goes to infinity. In other words, e to the x minus the nth Taylor polynomial has limit 0 as n tends to infinity. Let's pick any number d. This can be any number we like. It could be 100, 1,000, a Google. And we're going to apply Taylor's theorem to the remainder in the interval from minus d to d. And remember, we saw that in this interval, the absolute value of all the derivatives of f of x for any value of x in this interval are less than or equal to e to the d. So no matter what n is, the absolute value of this remainder is less than or equal to e to the d times the absolute value of x to the n plus 1 over n plus 1 factorial. And remember, we're free to choose any d we like here. Therefore, the limit as n goes to infinity of the absolute value of the nth remainder is greater than or equal to 0, and it's less than or equal to the limit as n goes to infinity of e to the d times the absolute value of x to the n plus 1 over n plus 1 factorial. And now that's just e to the d times the limit as n goes to infinity of the absolute value of x to the n plus 1 over n plus 1 factorial, which is 0. So we have 0 is less than or equal to the limit of the remainder, which is less than or equal to 0. So therefore, the limit as n goes to infinity of the remainder must equal 0. And this holds true for all x in the intervals from minus d to d. So this shows that e to the x equals the sum of its Maclaurin series, the sum from 0 to infinity of x to the n over n factorial for all x with the absolute value of x less than d. Remember, I'm free to choose d as big as I like. So if I want to prove that e to the x equals the sum of its Maclaurin series for some particular x, then I just choose a d in the above proof, which is bigger than the absolute value of x. And then I know that this equation holds true for all x's for which the absolute value of x is less than or equal to d, and this includes the particular x of interest to me.